Either that I can fix such. So I can fix. Yeah, you can start one.
So yeah, our next speaker is Satrajit Ghosh from Curable Research. She's gonna tell us all about the common workflow language.
Okay, I can adjust the lights. Is this okay, or do you want them down a little?
It's okay.
This is okay? Okay. I brought them back up because it was very dark in here. So as Paul said, I am Sarah. I am from Curaverse Research. We are a company that focuses on open science and open software and open data, and particularly in the genomic space. And thank you for inviting me today. Since there's such a small group, feel free to stop me at any time if you have questions. This is really a tutorial for you guys. You know, I could stand and talk anywhere. So, and today I'm going to be talking about the Common Workflow Language, or CWL. So maybe you guys can raise your hands. Who has heard of CWL before? Okay, so like half of you. And then who's using it currently? Okay, 3? Okay, good. For the people who aren't here, hopefully you will come knowing what it is. Come out of this knowing what it is. Okay. So today I'm just going to give a little background on what CWL is, an introduction to using CWL. Basically, I like to say it's enough to get you dangerous. So, you know, you can dig around and do things for yourself. And I'll stay for a couple hours if you want me to, if some people are going to start focusing on learning how to do it today. And then at the end, some resources to answer questions, some more tutorial information, things like that. Any questions before we get started? Okay. And I'll probably check in with you and make you talk to me. Okay. All right. So I have little notes here, so I'm going to move them around while I talk, just because I haven't given this talk before. It's a brand new one just for you. Okay. So CWL is a way to describe and connect command line tools or statements, functions that you want to run into workflows. When it was first written, it was primarily focused on data-intensive science, so you guys fit right in there. And one important thing about CWL is it's a standard, not a particular implementation or a particular software package. So there are many implementations in it. We'll talk about implementations of it, which is actually quite important. And it is open source. The fact that it is standard means that things you write in CWL are portable. They can run in different environments. They can run in different systems that support CWL. And when I say they're portable, not only are they portable in different systems, but different applications or different software packages that run CWL run in different places or allowed you to run in parallel, let's say, on the cloud or on clusters or so forth. A really important thing about CWL is tasks are isolated, and we'll talk about steps in your CWL workflow. That's equivalent kind of to a task. They're isolated, and you specifically, explicitly put in your inputs and outputs, and that makes it very clear what's going on, so that when you look at a workflow, you're exactly sure what's going in and out of each step. Any questions? All right. Why have a standard? So it supports collaboration. It promotes interoperability, which is really useful because, as we know, tools grow and fade. One is in favor, then another one comes along and it becomes in favor. So if all of them support CWL, hopefully it will be minimal changes you have to make to run from one tool to the next. And lastly, funding sources, and some of us do have to worry about this, those of us who work off of grants, also other funders, really like the idea of standards over proprietary or single source approaches. Okay, so why do you care? Why should you use CWL? One, as I mentioned, it's portable. It's reproducible. So we are really in the era of reproducible science. You really want people to be able to reproduce your work, to show that it is robust, it is reliable, and you want to be able to reproduce it. If you make a change and you get a different answer, you want to be able to go back and make sure you knew what that change does, or you know what that change does. And lastly, it's scalable. So it's really designed to be able to run large-scale workflows in cluster environments or deal with a lot of data, even on a local machine. Any questions? I'm going to keep answering until somebody has one asking. Okay, so introduction to CWL documents. So there are two types of CWL documents. One is called a CWL file and one is called a YAML file. Okay, the CWL files are typically written in JSON. YAML files are written in YAML, which stands for yet another markup language. Don't worry if you've never written anything in JSON or you've written anything in YAML. I will be walking you through it. I didn't really know how to write either, do anything either. Maybe a little experience with JSON, none with YAML. When I started about a year ago, it was not a blocker for me at all. You can use your favorite text editor to write these. There are some drag and drop tools for writing CWL workflows. I haven't ever used them. I just write mine in my text editor. I'm old school, so I do VI. But you can do your favorite one. Just when you do that, when you see something spaced over, these are spaces, not tabs. Don't do that because some CWL, it won't be supported in some CWL runners. So the CWL is kind of the core of what's going on. It describes your workflow. Okay? It describes what's going in, what's going out, and what's being run. The specific input values are described in a YAML file. And so you could run the same CWL with different YAML files and get different results because you have different inputs. And the CWL file and the YAML file are put together and run in a CWL runner. And the CWL runner is what's supported in different tools. That's kind of the thing that's a standard that's portable and used in different tools. Okay, so this is the implementation. On the left, don't worry about it, I've blown it up on the right here, are tools that support CWL. Okay. If you go to this common workflow, so it's commonwl.org page, you'll see a list of all of them. The ones that are in beta, you can see they're continuously being tested, so the ones in green are doing well on the test suite. And the two that we are going to talk about today are CWL tool. This is the reference implementation of CWL. This is what was first designed. It has everything in it that you want to get started. You can run it off your local machine. So I'm going to show running off my desktop. Okay. Then the other one I'm going to show is Arvados, which is the one I use mostly. It's also an open source tool. It's a heavier weight tool. It's for running with much larger data. We have ours running on the cloud right now. I regularly run anywhere between 100 and 500 nodes at a time. So, you know, it might not be what you need right now. Might be, depending on what you're doing. If you want to get started, or if you haven't installed CWL tool already, you can just go to the GitHub. You can follow that address, or I just Google GitHub CWL tool. Comes right up. There's a nice README right there. Takes 5 minutes to install. No problem. I actually did it the other day just to make sure I could do it live if I needed to. Okay, so all that talking, now we got to a CWL file. This is what it looks like. So in this case, I just want to untar a file, okay? This is what you write to do it. So the first part just tells you the file type. This is a command line tool. Basically, you'll see some other file types as we move along. There's 3 main file types, but this is the simplest. It's command line tool. Basically, I want to run that base command in the command line with some inputs, okay? So the executable, what I call the executable, is just the command that you want to run in the command line. Then after that, I have inputs. I define my inputs by their name, essentially, their type, and you can do this optional thing called an input binding, which basically tells what order you want to put the inputs as, okay? So in this case, it's the first one. We only have one, so we might have not had to put it as the first one, but we did just for explicit, just to make sure it's explicitly stated there. We don't have to. And also to make the demo make more sense. Outputs are defined the same way, name of the output, type, and you can do an output binding. And if it's a file, you'll do something like a glob. So I just look up what glob stands for. Anyone know? Global command. Anyway, Basically, it's a way to search for files. So in this case, it finds hello.txt. You can do wildcards. So let's say I didn't know if it was hello.txt. I could put something like star.txt. It would find all the text files for me. It would pick up hello.txt, which is the only output I had. Okay. Any questions on this? Yeah.
So what's the difference between the sample out and which is the output file? Where the output is going to go? So in the output section, you have like an says sample underscore output.
Okay, so the question was, what's the difference between example underscore out and hello.txt? Example, you can think of example underscore out as being the name of the variable, and hello.txt as being what's associated with it. So if later on in the workflow I wanted to refer to that variable, I refer to example underscore out, and you'll see that in the workflow. It will become more obvious why we would do that. Yep.
In the base command, you've got xf, and I guess that's the command to extract target, right?
Yep.
So you could also put that under inputs.
Yep.
So can you walk through how you think about that? Like when should it
Yep. So typically I think of inputs as something that has a parameter value with it. And often you have, and I'll show this in the next slide, you might even have a prefix before it. So like -I and then a word or something. There's another way to do this as well with an argument. I don't think it matters. I think it just determines on what you're most comfortable with and what makes the most sense to you. I have a lot of people who use arguments, which I'll show next, more than these. I tend to use these most of the time. I tend to explicitly state inputs, and I try to make my base command as small as possible, so it makes it as clear what's going on, but it's basically up to you. They'll all run the same way. Okay, yep.
So this is a little bit in the weeds, but so say I want to, there's some dash commands and some double dash commands, most Unix commands. When you do that, how does it know that tar takes a dash xf and not a dash dash xf?
So in this case, it's just doing a tar xf, which will work too.
Okay, so if you want to do a dash f command, you specify that as dash dash, right?
Yeah, yep, and I'll show you that in a second. All right, so this is the matching YAML file. So the YAML file is the actual value for the tar file, for the input that we want to put in, and it's, in this case, a file, and we give it the path. I'm going to run this live and show you what happens, but any questions on the YAML file? Yes?
Yeah, so it's like the CW file is also a YAML file, right?
Excuse me?
The C, the file where you implement the command is also a YAML file, right?
So the one on the left where I implement the command line tool, it's actually written in JSON. So it's, and you mark it .cwl, and this one you mark .yaml.
So can you write the other one
In YAML? I don't know. I've never done it. I can try to find out for you. The question is, can we write the CWL in YAML? I don't know.
the one that you can write in YAML.json is the input file.
So I mean, this is the schema you want to use to write it, though. You can't write anything in JSON that you would want. Yep.
The CWA document is also nice.
Yes.
Or you could write explicit JSON if you want.
Yeah.
With curly braces and all.
Mm-hmm.
Oh, okay, you can.
Yep. No, you don't have to.
Oh, I see.
All right. So let me pop over. I have a screenshot here, but let me pop over and run it live. Okay, so can everyone see that okay? Okay, so if you go to the CWL directory in GitHub, there's a user guide. So I'm just running some of the demos out of the user guide here. So it's user guide /include /CWL, and then this is the fourth demo in the user guide. Okay. So we see we have that same tar file and that same tar /job.yaml. So That's all you have to do. CWL runner, your CWL, and then your YAML. If you forget and reverse them, it will get confused. I have done that, and they've given me some weird errors, so put the CWL first. Oop. I know what I did wrong. So I installed it in a virtual environment, which is kind of the way that they usually say to install CWL so it doesn't conflict with anything else you might have installed. So let me just start my virtual environment here. Oh yeah, thank you. Much better. Okay, so this is what it does. So you can see the command that it ran here. If you look at the very top, so it says tar xf, so that's when you're talking about it doesn't use the dash, and then it copies the inputs into a temporary directory. It often copies things and runs them in a temporary directory, so it doesn't copy over something that you weren't expecting it to copy over. And then it gives you the out. And then the output path is the path that you ran in, so it copies it into that output path. And if you look here, you'll see now there's a hello.txt. Okay? You will also see that the size of this is 0. Do not worry, the tar file was empty. If you see in my screenshot, I do have a size because it made me very sad to untar an empty file, so mine just had hello in it. I did it to make sure it worked. Okay. Any questions about running this? Pretty straightforward? Okay. Yeah.
So obviously everything is static here, but in the real world you want to have dynamic inputs.
Mm-hmm.
Is the basic framework that as this runs along the way, it's going to be dynamically writing these job YAML files, or is there a way to specify a dynamic variable you provide that modify?
Yep. So there are ways to, other than writing it in the YAML file, so there are ways to write files on input. So have it write out files when it starts on execution. So there's the way to do that. You can also call it within something like a Python script. And so if you generate the inputs in Python, and then you can port them into the CWL runner.
You can also pass inputs on the command line, can't you? Or is that only for workflows?
No, you can work, you can get stuff from the command line as well. So all of that would work for you. All right, so we just saw an example of running a CWL process. It's doing the I/O at runtime. And we didn't show this, but this is a tip of the hat for things that are to come. You can store requirements in your command line tool or your workflow. So whether they be a Docker container to run in, maybe if you are running on, let's say, the Arvados or Toil implementation, you can tell it what, I assume Toil does this, I know Arvados does, how many cores you want to run in, what your maximum RAM is. You can do all of these things as well, specify them. Also specify if you need a particular environment variable set, things like that. Okay. So a little bit more about inputs. There is a lot of types that you can use. The ones I end up using the most are strings, arrays, files, and directories, but your workflow might be different than mine. We talked about input binding. So again, one of the things is position. Somebody asked about what if you need a dash dash or something like that in front of your input. In this case, it's doing a dash I, but it could be anything you want. And then there's a separate, whether you want a space between that prefix and that input variable. Okay. Any questions on that? Okay. So I alluded to this before, is that there are other ways to do inputs. The first is if you want to do arguments, and usually arguments are for things that in the doc they say correspond exactly to input parameters. You know how that's a little wishy-washy, right? Because you can make that decision. In this case, dash D maybe corresponds to input parameter, maybe doesn't. So it's up to you what you think makes the most sense in your workflow. And you can also pull runtime information. So you can pull the output directory, the input directory, the number of cores, the RAM, anything like that that's runtime information about your machine you can get. So one example that I use all the time is that I run something multi-threaded and I don't know which machine it's going to be running on, so I pull the number of cores. And so then that's an input to the program I'm running, so I do dash in, and then I do runtime dot, core min, something like that. Inputs also, you can do optional inputs. So let's say you have an option where you have a default value, you have a case where you have a default value, but then sometimes you put another value in there. You can denote that either making it type null or do the type that it could be with a question mark after it, and that will let you say it's optional, and then you can send a default. This is actually a snippet of code that I wrote. It is a default value, which is this bash script, and then I have a question mark in case I don't put it in, it will default to that value. Any questions there? Yeah. Yeah.
So the first one is with these arguments, right?
Mm-hmm. Yeah.
What's the sort of ordering in the inputs? Does that come before, so there's input binding there,
Mm-hmm.
right? So is it going to be Java C and then those arguments and then all your input bindings?
That's a good question. I think that it puts the input binding first and then the arguments, but I'm not 100% sure. I can find out for you. So the question was, sorry if you're recording this and can't hear the questions. The question was, what does it do first? If you have both arguments and input binding, what does it do first? And at first I want to say arguments, but then it kind of ruins the fact that you've said it's position 1 for the inputs. So now I don't know which it is, so I'll find out. I mean, we could try it, but I don't know off the top of my head, yeah.
And I've been trying to play around with these optional inputs, right?
Mm-hmm.
So here you've got an optional file input,
Mm-hmm.
and the default is to point it to a particular file.
Yep.
Right? So you could override that and point it to a different file.
Mm-hmm. Yep.
But since it's an optional input, you should be able to override it and say no input at all, right?
Yeah, if you didn't put a default, you could just put optional, and then it would be nothing. It would just...
But if you do have a default, how do you override it to say nothing?
Oh,
Hey, it's fine. I'm just...
You could probably feed it in as a... That's a good question. You probably can put multiple defaults, is my guess. But let me find out. So the question is, if you want a default, but you don't want to use either the default or putting in nothing, you want to actually put in nothing, how do you get that to happen? And I will find out for you. I don't know. Let me think about it. I have never done it before. It's a good question. Yes.
So is there any text within the types? Say for example, if I have I'm asking for a type file and the file doesn't exist or something. Is there anything that the program is doing or is something that I have by myself?
So if you ask for a type that doesn't exist or you ask that for a file that doesn't exist, it'll give you an error message that makes sense. So Usually it's something like, I cannot find the file located, blah, 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 and it gives you the string that you're looking for. Type, it probably will say this type isn't supported, something like that. You can, I've never done it because I've never needed to, but you can make custom types. So you can import like a namespace and have custom types if you want to. I've never had to do it, but you can do that if you need something beyond what's available. Was there one over? Yeah.
I just want to ask a request from audience that are watching from different cities, that if you can repeat questions.
Yes. I'm trying, but I will try harder. I'm sorry. I will try harder to repeat questions. Sorry about that. Remind me. Be like, repeat. All right. And then there's the option to do exclusive or dependent parameters. So if you put in this value, then this value doesn't need to be set, or these two both have to be set at the same time, basically. And you use that using the type record. In this case, A and B both need to be set, and it will give you a message, you need both A and B. Where it says name dependent parameters, you can do a similar thing where it's name exclusive parameters, and it works similarly. Any questions? Okay. All right, outputs. Similar thing. I discussed output binding. You can do a wildcard pattern. You can also, we'll talk about arrays, so you can feed it back multiple files if that's the case. And you can also do standard out and standard error. So the way to do that is you define standard out to a file, and then for your outputs, you list standard out there. Standard error as well. Yes?
So I was having problems when I was like creating multiple subdirectories. And I was having problem with like using these files as an output to my workflow. So is it like any kind of requirements that I should be aware, or?
No, I don't think there are any requirements. I think probably it just wasn't finding them.
It was using in one of the steps. So it was not like, so it was, I didn't have any errors during the steps. I was just having errors at the end when I was asking this output of the workflow.
Okay, so the question was, she was having problems. Were you writing out to files or writing to files that already exist?
No, I was creating this file within some subdirectories that I was creating in my way. So I was thinking maybe there is some requirements that you cannot.
There are no requirements. So the question was, are there requirements for output, like directories or things like that, when you're trying to use like a glob to find? Not that I'm aware of. You might want to do the whole path, and then.
Cannot have, because there is like this intemporary directory. Yeah.
You can use the runtime outdoor.
Yeah, so by default, it will put it in the, well, but that should be fine because it should be relative to where it's running. So if she makes, let's say I'm running in the runtime directory and I make a directory, it should pull it up from there. But it is true that if you want to save explicitly to your input directory or your output directory, you can do that. But maybe you should, do you have it? Yeah. We'll look at it afterwards. Yep. Any other questions? Okay. All right, so I use arrays all the time because I deal with lots and lots of files. So arrays are just what you think. Arrays, a list of many strings, or arrays, many files, many directories. You can do the same thing, that you can either do a type array and then underneath it say what the array contains, or the hack that I usually use is you just do the type and then you do bracket bracket, and that says it's an array of that type. Sometimes I have arrays of files, and then I have to do the nested definition, but often just the brackets help me. You can use input binding if you want something in front of the array, or to do a prefix between them. if you want to separate them, all of the things that you would maybe want to do in a command line tool. And then often what I do is I do a glob that's like star.txt, and my output type is a file array because I might be getting multiple files back. Okay. Any questions on that? Okay. So this is the second type. So I said the first type of CWL file is mostly is the command line tool, and it's mostly for running command line tools. The second is expression tool, and this is if you really want to write a JavaScript in there and run it on some of your inputs. This is usually useful for me when I have to move around files or move around directories, things like that, because it's a pointer to the file. So I'm not actually copying them around. At least that's true in terms of when I run in Arvados. So what this one does is, it's a little confusing, so stay with me. When you put something in a scatter, which allows you to run it in parallel, we'll talk about a scatter in a little bit, it needs to be an array. But if I look at files in a directory or directories, subdirectories in a directory, they don't immediately come in an array, so this looks at everything in my directory and puts it in a nice array format so I can feed it into the next step in my workflow. So it's just showing you how to write inline JavaScript. You could also do it if you have to, I don't know, create an array into the next step that you don't want to, shoot off to a Python script or a Bash script or something to do. It's good for kind of manipulating inputs when you just want to do kind of something simple and you don't want to go out to a command line tool to do it. Any questions on that? Okay. So, I mentioned that you can use Docker. Who here uses Docker? Okay, about half, I would say. If you want to continue using Docker and CWL tool, you can. It's pretty easy. Just in the hints section, right? You can, usually I put it above the base command, but you can really put it anywhere. You just put your Docker requirement, and you can do a Docker pull, or you can provide the Docker file and it will build it for you. And then you can run in that Docker file. CWL automatically takes care of the file shenanigans that have to happen. So any input files it makes possible to run in the container, anything that creates in the container that you have listed as an output, it'll make available outside the container. Okay. And this is, again, one of those things that are really useful to do for reproducibility, because then you know exactly where you ran it. Any questions on that? The other thing I wanted to mention is usually you need root privileges, or you need someone with root privileges to approve you to run Docker. If you run into that problem, there is something called, I believe, uDocker. I don't know if anyone's used it before. I think it's called uDocker. Somebody can Google it for me real quick. And it allows you to, as a user, run the Docker. So if you run into that problem, that might be useful. And CWL supports uDocker as well. Just some best practices. Probably anyone who knows who's used Docker before knows that they get big after a while. So it's because you can define a Docker for each CWL workflow, it might be useful for each workflow to have a separate Docker container if they start getting large on you. It depends on how big is too big for you. And also just when you make changes, if you have to continually keep making changes on one massive Docker file, you have to rebuild it every time, which gets a little cumbersome. And I just wanted to use the whale because he's cute. All right, so all of this has built up to workflows, which are really, I think, the key part of what you'll probably be using in CWL, which is that you can combine other workflows, command line tools, and expression tools as steps in a gigantic pipeline or gigantic workflow that you want to run. The class is workflow, just like we had class of command line tool. And in it, you specify data dependencies between steps. So one step will run, you'll say these outputs get passed to the next step, and so forth, till you define your outputs of what finally gets output from the job. I'll show you an example in the next slide that will make more sense. You can nest workflows. You can do scatter or gather to do parallelization. And they don't support conditionals or looping right now. It's something that they're currently working on for the next version of CWL, but there are workarounds to be able to do that, often using optionals or using JavaScript within your variables. With doing JavaScript to work on your variables allows you to do something like conditionals. Okay, so let's look at this workflow example. So there's two steps. The first is you're untarring a file, and then you're compiling it. It's a Java file, but you're compiling it. The CWL to untar is in this tar_param.cwl, so that's what we want to run in the first step. And then the second step we want to compile, and the command to compile is in this arguments.cwl step. So the first part of the CWL, and let me explain, this is all one document. It's just the top part of the document and the bottom part of the document side by side, so I can show you what's happening. So it's all one document. Don't think it's two. So first you say, okay, what's going into this workflow and what do I ultimately get out of the workflow? So define the inputs for the entire workflow and the outputs for the entire workflow. And then you can pass the inputs into one step. So imp and x are going in and getting passed a tar file, an extract file. That step runs. It makes example_out. And then example_out gets passed as the input to the next step. It takes that untarred file, and then it compiles it, and it gets the output. And then that gets passed to the output source, which is the final thing that gets outputted from the workflow. Outputted? That's not a word. Output from the workflow. So basically, it's a way to stack all of these together. Each step could be an expression tool. It could be another workflow, or it could be a command line tool. Yes?
Do you only specify one file or a final output from a workflow, or can you specify outputs along the way?
You can specify outputs along the way. So let's say I wanted my I can name them. So in this case, I just have one output source, one output listed. But if I had like a tar file or untar file, and then I could just say its output source is untar/example_out. So I can just reference the other steps. Yeah. So if you have something you want to bookkeep along the way, that you can pull them out, definitely. Questions? Okay, so let's run it. So again, if you've downloaded the user guide, this is number 21. Okay. All right, so it ran. Let me see if I can. So this is running in a Docker container. So you first see it running Docker. You see it's mounting those volumes that it needs to with the data that it needs to use. Then it runs the first step, which is the untar, which is somewhere here, believe me, is the untar. And then it's going to run that second step, which you see at the end, which is that Java C compile statement. And that's it. The output is done. And then we see that we have that hello.class as being the output, variant output. All right. All right, so I've zoomed in here because I was having trouble finding these. So you can see it's running, it starts the step and then starts the jobs in the step. So it starts step on tar, and then it does job on tar, and it does step compile, and in this case, I had to pull the Docker file the first time I ran it. Yep.
Can you cat or show the other two CWL files? I'm curious, the first workflow.cwl is of class workflow, and the other two are of class node?
No, those are of class command line tool.
Okay.
The node slim is the Docker container that it's pulling down. So let me just open them for you. I'm just going to go back to the command line. So the question was, what are the CWL? What does the CWL look like that the steps are running? So here's one of them. It's just compiling the Java. So it's a command line tool. You can see how to put some metadata in there. It's pulling this Docker container, and it's saving in the out directory. Okay. Do you want to see the other one? It looks similar. I can show it, or yeah, okay. Untarring. And this one again is a command line tool, but it could be expression tool, or it could be another workflow. You can nest workflows as well. And then again, this is just it finishing up and telling me that I had success, I ran successfully. All right, so one of the last things I wanted to talk about in terms of writing CWL is this idea of scattering. So what you can do is you can put an array of inputs into a step, and then you can scatter over it. So basically run that command that you have as the run command, the executable, over each of those inputs separately. Okay, and it's called scatter. So if you are able to have many machines, and you're running it on a cluster environment, then it will run an embarrassingly parallel job. It will run them all at the same time. Otherwise, it can run them serially for you. It's nice if you have a list of files, and you just give it an array of files, and it runs on each one for you. There's also the option if you have, let's say, 2 input arrays to do either a dot product, so match them one by one. So for each set, you run once, or to do the cross product, so it's every combination of them if you need to do that. And it just takes care of that for you so you don't have to write it out. Was there a question?
Yeah, so maybe it's also like too specific, and I can show you later. So I was trying to do like the out product between like scatters from 2 different steps. Have you ever tried to do it?
The output of...
So I have scattering the first step, and later I want to scatter more.
Yep. Okay, so you have, yeah, so you can do that. So the question is, can you do a scatter, get an array back, and then do another scatter on that array?
Yes.
You should be able to, yeah.
So I will show you.
Yeah, we can try to figure it out, yeah.
So it's possible.
It's possible, yeah, and you can nest scatters, so like, yeah, exactly. So it's basically you have to nest the CWL with the scatter in it. I've never, no, that's wrong. I have done it, I think, once, but we can figure it out, yeah. So then again, that's the way you do running one thing on one command on a bunch of different inputs. Okay, so I have about 15 minutes. I just wanted to show maybe in the next kind of 5 minutes what I work on. So I work with a system called Arvados, which it supports CWL, and it's an open source platform for processing big data in a reproducible way. So it has 2 components. The first one is Crunch, which we call our workflow manager, and it runs CWL pipelines. It can run anywhere. So it can run on your local machine. It can run on a cluster, on the cloud. The one I'm running I'm going to show you running is on Azure. It manages all the compute nodes and installing the containers and handling the data. And it uses Docker to do that. And then Keep is the file management system. And so this is where we store all our big data. It's a content addressable storage system, which makes it very nice for me because I know that if it can check that I'm actually pulling the bits or bytes or whatever you want to say, the bits I think I'm pulling. I know I'm getting the data I think I'm getting. If I download the data, it's the data that I think I should be getting. It basically also eliminates waste. So if I make a copy of data, it won't make a copy unless I change it. It's easy to move things around. And it has flexible permissioning, so you can, let's say, within a lab or within a work group, have certain people be able to access data and certain people not be able to access data, which is really useful because we deal with some data that has really tight permissions. That's genomic data, because people don't want just anyone looking at their genome. All right. So in general, what do I use CWL for? Well, I do genomics, and what I work with is this technique called tiling that we invented in the group I work in. And basically, it's a way of condensing a genome into smaller tiles, and they're defined by base pairs, by base pair tags, which are 24 base pair. They're tags that are 24 base pairs long. And so the whole genome can be broken up into these tiles. They can be variable sizes. They have to be 250 so bases long, but if they can be bigger than that. And then we put all the possible tiles in a library, and then we can reference the genome just by referencing into that tile library. So instead of having 3 billion bases, we end up with 10 million tiles, and that helps us a lot in terms of memory usage and being able to compute on it much faster. The other thing that's beneficial, it's open source, so anyone can use it. So once you tile a genome, somebody also could use that tiling information and know what they're doing and how you got it. And it's standardized, which is really important because we can extract away what the reference genome was, what the input format was, who sequenced it, whether it was genotype data or whole sequencing data, that all of that information we kind of extract away because we're really dealing with the base sequence. And then the thing that I particularly work on is I take all these tile genomes and I do big machine learning on them to try to find tiles or variants of interest. So things that could be predictive of disease or a risk factor for a disease, let's say like Alzheimer's, or drug targets, things that are important for treating a disease. And just to make it seem more real, well, this is actually real. This is for a particular person. This is a tile that's located in chromosome 19. Highlighted in yellow there are the base pair tags, the base tags. And then highlighted in blue is if you compare this tile with a reference tile, it's the only difference. And that corresponds to something called the EPOE variant, which is a variant which is thought to be causal for Alzheimer's. And so if you have both of these variants, T on both sets, you're homozygous for EPOE, you have about 11 times more likely to get Alzheimer's. So we did a test case where we had cases and controls for Alzheimer's, and we picked out this tile. It's one of our test cases, things like this, to make sure we're doing the right thing, we're getting the right answers before we go off and look for new discoveries. So that's what I do. So just to show what Arvados looks like, I'm going to just run a simple job of the CWL workflow that we did before so you can see it running. And then I was going to show a larger computation that I ran this morning on 20 nodes. Just to show you what it looks like when it's run. And in this case, it's creating this thing called a CGF, which is a compact way of storing these tile genomes. So if I log on to the cluster, this is our cluster SU92L. The name was randomly generated. It doesn't mean anything. It's running on Azure right now. And this is the workbench or the dashboard to running our Vados. You can do a lot from the command line and a lot from the workbench. Everything you can do from the workbench, you can do from the command line. There's some special stuff you can just do in the command line, though. So you can see these are things that were just run. You can see that I ran a test this morning to make sure I could actually run this code on it. If I look here, these are projects. I have my favorite ones bookmarked, and so I'm going to go to the brain hack examples. And you can set it for any project. You can set things like descriptions, but you can also have collections of data that correspond to a project. So we could look at one of these. And each one of these, this is data just from one of my runs. It has a content address, which is basically a hash of the information that's in this particular collection. It's like a hash of a hash. But you know that when you put that number in for that collection, you get that data, right? So you know exactly what you're getting when you ask for it. There's also a UUID, which is a name for this collection. So if I change the underlying data, the portable data hash will change, but the name of the collection won't. So it's kind of two ways to reference your data. In this case, you can also get content size and other information. So let's run something and see what it looks like. Oh, before I do this, there's this tab called Pipelines and Processes. These are things that are currently running or have run related to this project. And you see I've run some of these before, and I can click on them and get information about them. I'll do that after I run a new one. So I can't SSH. So also, our Vados allows me access to a virtual environment, so I've logged into that, and I'm going to run from that instead. I'm using the guest account at MIT, and it won't let me SSH. So here we see that tar.cwl and that tar job YAML file, the same ones that we had before.
Sarah, if you wanted to SSH, you can just use the regular MIT account.
Oh. Oh well. I will do that later. I don't want to set it up now, but that's okay. Thank you. So in this case, CWL runner maps to my Arvada CWL runner. And then I want to give it some flags. The first one is this one called no wait. Oops. Basically, that's telling me to submit the job and return back, not to wait for it to finish. Sometimes you want to wait if it's a simple job. In this case, I don't want to wait. You can also give it the project UUID that says run in this particular project for me as opposed to running in my general directory. This is important if you have a project with limited permissions. Let's say I'm running on data that I don't want everyone to be able to see or access, then I want to run in my particular project. It's also good just for organization. You can move it later, but I found just put it in the right place to begin with makes my life easier. So if I want the UUID of that particular project, then I just go and I can get it just straight out of the URL, which is, I find, the easiest way. And then there is backwards compatibility. So I'm going to put a flag that says run the latest version. I can't see it, which is a bit of a problem. Let me see. And now I just put in the CWL and YAML. And you can see what the error looks like when I do something wrong. Let's see. Choose a returned owner ID. I'm just going to run it. It's having problems with the virtual environment seeing my project, so I'm just going to run regular. All right, there we go. It's probably since I'm using this virtual environment, so I apologize there. So it's submitted, it's ready to go, and then I can look at it running. By default, it will run in my home. We see that it says it's already complete. So what's going on there? So let me double check this is the one that I submitted. Ah, smarty. So what happened is this. It was too smart for me. If I submit something that's been submitted before, it knows and it doesn't rerun it. It just points me to the old one that was rerun. So basically it's telling me this has been rerun already. I believe there is a no reuse flag. Disable reuse. Let's do that. There it is. So what happens is if it knows that you've already run it, it will, or run part of the workflow before, it will see that it has the same inputs and outputs, the same file, the same Docker file, everything is exactly the same, and it won't rerun it for you. This is useful for me, like if 90% of my workflow runs and the last 10% doesn't, it jumps through it. So now we can see it's queued, and we'll wait for it to run. The one that was the large run that I wanted to show you looks like this. So this is one that I ran to create these CGF files. It's a workflow. It does a scatter over 20 files. So these are my, what it looks like is it gives me the UUID for the run. It tells me who ran it. It gives me all kinds of information there, where my Docker, image Docker is. It gives me all my inputs. There we go. And then it has all my steps, and they're listed in when they finished here, but you can dig into each step. Each step will tell me information about that particular step, when it was run, what was the input to that particular step, In this case, each of these files were different. This is the file I was scattering over. I could go in and look at the log for each of these steps. Oop. Oh, this went black, but we're okay. The log for each of these steps, I can get information about the nodes. I can get standard error. I can get standard out. Then you can see standard out to the screen as well. Okay. If I can get output by step, or I can get all of it collected together. How I prescribed in my workflow with outputs, it outputs it in a new collection for me. If that collection mirrors another collection, let's say I've rerun something or it's the same output, it won't recreate it, it'll just point me to the one that already exists. And in this case, half a gig there. And then what we can do is if I want to share this with someone, I can create a sharing link, and basically this is a URL that I can give them, and if they click on that, then they can do a wget and download all these files. Don't worry, this is not, the information I'm using is from the Personal Genome Project, so it's all publicly available. I'm not giving away anyone's secret information. All right. And I think this one is queuing. So when you first start up a node on the cluster, it takes about 5 minutes, and then they'll keep them up for about 20 minutes, even if no one's run on them, and then take them down. So this one will take about 5 minutes to start up time, then you can run on it. So we can touch back in it, but this is like what it looks like when it's running. It'll tell you that it's queued. It'll give you information about what you're trying to run and information like that. Okay. All right. Okay, so there's a bunch of stuff I didn't cover because I didn't want to keep you here forever, and I'm already 3 minutes over. So you saw a little bit. You can provide metadata about your author ownership and labels for inputs if you want to add that. We mentioned you can create files at runtime, which is one of the ways to dynamically create inputs that somebody asked. You can specify software requirements. You can put input files into the working directory. Sometimes tools will only look in the working directory where the tool is located for files. You can do that. You can use JavaScript expressions in value from to manipulate or create input parameters. So let's say you needed to create the values 1 through 10 or something. You could do that in a little JavaScript in there. And you can set environment variables as well. And if you want to see how to do any of these things, there's in the tutorial there, or I'll be around and I can help you through it. And these are the additional resources. There's a user's guide, which I mentioned. There's the language specifications. So if the user guide isn't enough for you and you're really digging deep and you can't figure out how to do something, the language specifications are often useful. Or do you guys use BioStars? Are you part of that community? Somewhat. You can go on BioStars. It's like /dot for biologists, but nicer. And you can just look at the tag CWL and people ask your CWL questions. Most of them will be answered by the developers of CWL, so they know what they're talking about, and they're extremely helpful. They're not going to be mad at you or anything, no snark. And that's it, I think. Sorry for running a little over. And then I'm happy to stay and help people get set up, answer questions. That's about it. And the PDF is available. So that's it. Thank you. Yeah.
It doesn't sound like you do a lot of PR research. But there's I guess a workflow language called MindPipe that basically does a lot of what you just talked about. So it lets you link together FSL and a number of other analysis packages. Are you able to provide pros and cons for using NightPipe for neuroimaging versus CWL, or is it outside of your expertise?
It's probably outside my expertise. Okay. Yeah. I mean, it's something you could post a question like BioStars or ask like Peter about that because I don't know it well enough. I can give you my card and you can email me, and then I'll just forward it along to Peter and see if he
I
knows.
suspect there are people in this room who are playing
Yeah.
so I can.
So, also like, that for CWA you can use every,
I'm sure you can use what?
you can use every command line tool.
Mm. So
One
MindPipe
discussion,
doesn't.
but- and I think we will also want to have converted between CWA and MindPipe.
Okay.
So I think we're not doing it really.
So you think
But
basically.
sometimes you have like
Okay, well, that's fine.
better person, but yeah.
It's called MindPipe.
Night pipe.
Nine. Oh, gotcha. Okay. Yeah, let me get you my card, and then you can just email me, and I'll see if anyone knows. Yeah.
I think
'Cause-
one distinction is like this is a spec. I don't know too much about MindPipe, but it's like the specification and the execution.
We have someone answer. Not that I did not ask players yet.
So a lot of the stuff that Night pipe does, you wouldn't be able to do. with
Maybe
CWL,
because I-
there's not a command line tool. So if you want to do something with this ASPN, so you need to go to command lines. Thank you so much.
Yeah, that's fair.
This is like.
But you know, a lot of stuff, so you want to do it all in.
But it's actually what I
It's
do.
easily through CWL, as long as you're willing to go through every step of the MSL process and
So
say,
basically the idea is just.
Translate it to command line.
Yeah.
First step, I would like to run
It's
for
interesting,
like
so MindPipe
multiple
lets you
like
like drop in and then
subjects,
you start
like my water.
writing Python and then correct.
And later I wanna have like
Yeah.
multiple tests.
On each subject.
On each subject, but I don't wanna have like scatter.
So if you want to,
Because I don't wanna have
you
like.
want to have a piece
run
from
the first
asking, a
step,
piece from MSL, a piece from SPL.
So in
Then
the OIL,
you
I
can just
can
You write a Python wrapper
for
script
each
that basically
subject,
creates a working,
values.
much the same way this does, where you specify the inputs and outputs.
But the first,
Then you
the
say
first
go,
part,
and it does
because
exactly
I'm
what it says,
work
creates a
for
working
my
directory.
project.
Then it creates hash, or, you know,
It's the part that takes the most time.
Mm-hmm.
So I don't wanna
creates
have
hashes
like,
for things this already runs, so it
I don't
doesn't
wanna
run.
have like this part for every single step.
So it sounds like there's a lot of people.
So I wanna run like the first one for every single subject.
What the advantage?
And later I wanna.
Oh,
Yeah, oh, it's awesome.
Picture here?
Yes.
That will help me.
Yeah.
Okay.
You know what, I might just, I know Dora is doing more advanced things than you with CWL, so I might just like listen in if you don't mind.
Oh,
Oh,
yeah,
yeah,
yeah.
sorry, I thought that maybe you.
No, I just like, cause I
Because
haven't,
if you have something quick.
no, I mean, I know you're doing scatter and combine and stuff, I haven't even touched that yet, but I'd like to learn that.
Oh, yeah, I don't know much.
Okay, cool, thanks.
I was hoping I could.
Basically, I have like one step, it's one. But I also can work on some maybe I should code work.